Hey, what's up, guys? How's it going? In this video, I'm going to go through LeetCode question number 78, subset. And this question was very popular from Facebook. As you can see, the frequency distribution. So Facebook was asked like 11 times, and also 6 times from Bloomberg, and from Google, BitDance, and Microsoft, Amazon, Uber, and Goldman Sachs. So this is one of the most popular LeetCode problem, and it's pretty straightforward. So let's take a look at it. So we are given a integer array nums of unique elements, and what we need to do is to return all the possible subset, the power set. So the solution set must not contain duplicate subsets. Return the solution in any order. So this unique is very important because that means there will not be like repeating elements in the set. So 1, 2, 3. That's one of the possible input. Or we can have 1, 2, 3, 4. But it is not possible to have like 1, 2, 3, 3 or 1, 2, 2, 3. So the output, expected output is empty set, and also 1, 2, and 3, so which contains the individual elements and not the others, or either 2 of the elements, 1, 2, 1, 3, and 2, 3, and then there's just any 2 of them, or contains everybody, so it's 1, 2, 3. So the number of elements, not the number of subset, will be 2 to the power of n, because each element has a choice, have 2 choices. Either the elements stayed in the set or is out of the set. So each element has 2 choices, and then we have 3 elements, and each one makes decision individually, and that kind of follow like a binomial distribution. And then the total number of possible set will be 2 to the power 1 of n. In this case, 2 to the power of 3, so which is 8. So we can see like a 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 subset. And in this case, we have where we have only 1 element, so 2 to the power of 1. So we have 2 possible subsets. And there are multiple solutions for this problem, and I'm going to show mine. So we first have a return list, and so this is the one that we will be returning. Oops, I'm going to return this guy again. Return list. So, and then we have a for list, which is a copy, which contains everybody, which is a copy of the nums. And then if that input nums or list is empty, it's empty list, which is this is a trivial situation, and you should return a empty list because it has no subset in it. It's a trivial situation. And then if this is not an empty list, and then what we need to do is to work on this return list, and we have to. The first one is easy. You just add the base case, which has an empty list in it, and then we need a helper function named remove1. Basically, we recursively call this function. Let's take a look at it together. So if this given list is not an empty list, and if this given list is not in the return list, that will be returning. So that means it's a list that has been not worked on before, and also it's not empty. And then we will append this list. We will add this list, a copy of this list to this return list. And the reason why we need a copy of it, because if we don't do that, it will just because it just points to that list in the memory. That's why we need to work on a brand new list to avoid ambiguity in the memory. So for each of the elements in this given list, we pop it off. We pop off each element one by one. So what I mean by that is, let's say the first one. Sorry, I didn't paste the last 3 lines of code on it, and then now it has been fixed. And let's come back to the solution. So let's see. We first have the for list, and the for list in this case, let's say is a 1, 2, 3. So we call this function by inputting this for list 1, 2, 3, and this is not an empty list, and it moves on. And this is, let's say this is not in the return list, which is in this case right now is empty list. It's not in it, so we will carry on, and then we will put this for list through this return list. This is what it does. And then what we need to do is to loop through each individual items in this list, and this is what it's doing, like index in this range of the length of this for list. And then each time when this is looping, it pop off one of the elements. So let's say if when the index is 0, which is points to the first element, it pops off that element. So we have the temp, which is a copy of this for list, and then pop it off. And then after we pop it off, we put the list of the 2 and 3 back to this function. In this case, the temp has 2 elements, which is 2 and 3, and then it is being run again for the index when index is 2, when index is 1, which is point to the second element, and then we pop off the second element, which 1 and 3 will be remaining in the list, and then it's called on this function again. So it recursively call itself, and each time it pop off one of the elements. So that's how we get all the children of all the children, possible childrens of the for list. So we pop it off each time, and then call the function call the function recursively by itself. And yeah, so this is how it works. And for the case of the 4 elements, it's the same idea, right? So the first time we pop off the first element, so we are left with 2 and 3 and 4, and then for 2 and 3 and 4, and then we pop off a second element, we're left with 3 and 4, and then we do it again, and then we're left with 3 and 4 individually, and then we recursively call this guy, and then the next time we pop off the second element, and then we have 1 and 3 and 4, and then we do it again. So for the complexity analysis, this is the n times the 2 to the power of n, because we need to recursively call the function. We need to call this function like a 2 to the power of n times. And each time when it's append, we need to copy all the elements, and that takes times as well. So that's n. And for space complexity is the same. The big O of n times 2 to the power of n, because each subset has a length of n, and there are 2 to the power of n of a possible subset. So that's why we need that much space and that much of time. Okay, so this is my solution, and I hope you like it. And if you like this video, please hit the like button or consider subscribe my channel. And yeah, thank you so much for watching. See you in the next video. Bye bye.